Hi, welcome again. I'm Sabir. So in this lecture, I'm going to make you understand what is the summation convention. So in tensor is the part of tensor. SUMMATIO and summation convention. Number one, number two, dummy dummy indices. Three, free indices. In DICS. Okay, so these are really important, especially if you study the tensor. Then we must have to know what is the summation convention and what is the dummy indices and what is the free indices, because these are the very basic concepts. Okay, let's get started. For example, here we have a linear equation. Say here S equal to a1 x1 plus a2 x2 plus a3 x3 and up to the nth term here, right? an xn, right? So here this is the linear equation, and here every part we have a different parts. Here part 1, right? In this equation part 2 and part 3, right? Up to part n. So we have n parts to sum up. Yeah. So in every part, if we look at this every part, there's a two indices here, a1 and x1, right? And a2 x2, a3 x3. So if we see that the indices here at a is 1, indices here at x is 1, so both indices at a and x1 is same, right? Here the a1 and here the a2. Okay, so I'm going to change the color so that you can make you understand. It'd be better for you. Yeah. So here it is. Here it is 2. Here it is 2. So both indices at a and x is same, right? So here at every part of this equation, indices at both terms is same, right? Okay, so we can using the summation convention, we can write this equation in a compact form using the summation sign. So right, as we have this, so how we can write in compact form? So for example, here as it is sum several terms, how many terms are here? 1, 2, 3, and up to n term. So summation sign. So if you use the summation sign, for example, I equal to, say here I equal to 1 to up to how many terms? N term, right? So and how we can write down in compact form this whole terms here? So here we have a and x, right? So both indices at a and x are same or equal, right? So 1 1 2 2 3 3 or n, right? So we can write down here j and j. That means if we write down the indices here j, and we should also write down the indices here f1 j, right? So it is obvious that it is obvious that we can replace this equation here at following equation. Say here s equal to, we can write down the same equation here. Say I equal to up to 1 to n term. Here ak equal to xk, right? So it doesn't matter in which form and which symbol we are using to express our indices, so it doesn't matter at all. So we can write down s equal to summation I equal to, say, k I equal to 1 to n. We can write down here amxn. So it doesn't matter in which form or in which symbol we are going to write down our symbol, our indices, right? Okay, so this is the summation convention, how we can transform a equation to a compact form with summation sign, right? But Einstein's, that is another convention, Einstein's summation convention. Einstein generally tried to avoid this summation convention sign, and that's why it is called summation convention. So how we can write the summation convention? So we can write down the above equations, this equation in the following terms here. So for example, here s equal to, we can write down aj xj. So this is, we can also write down the above formation, above form to a same exactly as this form. without the summation sign, without this summation sign here. And if we write down here, then it's called the Einstein's convention summation. So if we see any compact form like that, say successive indices are same, or successive, yeah, or repeated indices are same, then we will understand that it's the summation. So if we say, for example, if we are given s equal to, say for example, mx and x, then what we can do, then we can sum up this here. We can write down this equation here: m1 n1 plus m2 n2 up to the term we are interested to, right? So mn nn. So these are called Einstein summation convention. So we can write down. So it is emphasized that expression something like that is not defined as this convention. So we can understand that repeated indices are used as summation. Yeah. So here we have only the triples of one sum, right? So we can have double sum, triple sum, and multi sum. For example, I can give you an example right there. So if we have, say, s equal to double sum here, I equal to 1 to, say, 3. Here summation j equal to 1 to 3, and here say xi yj, say for example. So how many terms are here in this equation? How many terms are there in this equation? You can out. So we have 3 times 3, so we have 9 terms here, right? Yeah. So how we can write down this equation as expression here? So at first, if I say I1, then all the terms should be j. So x1 y1 plus x1 y2 plus x1 y3. Similarly, we can write x2 y1 plus x2 y2 plus x2 y3, right? And similarly, then we can write down this, sorry, x3 y1 plus x3 y2 plus x3 y3, right? So here we have 9 terms in this equation, right? Because we are given the two sum, and in each sum we have 3 parts, right? So in each sum we have 3 parts. So we have if we write down the triple sum here, then we'll have then, say for example, here we have triple sum combination I equal to 1 to 3, another sum I equal to 1 to 3, and the sum I equal to 1 to 3. For example, here xi, sorry, I, this is the j, and this is the k, because we have to use the 3 different xi yj, say for example mk, right? So we have 3 different indices here, I, j, k. So we have here 3 times 3, 3 times 3, we have 27 terms. So the first term would be here x1 y1 m1, right? The second term would be, say, we can write down x1, sorry, yeah, x1 y1 and m2, and so on. So we will have 27 terms here. So these are the summation convention or something like that. So you can express triple sum, double sum, or something like that here in this way, right? Yes. Okay. So another important terms here is the called dummy indices. Then what is dummy indices? DAUMY, dummy, INDICES, dummy indices. So what is dummy indices? Dummy indices is nothing. So if we observe carefully here in this equation, the summation doesn't depend on the indices here ij, right? But the summation depends how many terms we are interested to calculate, right? So it doesn't depend on the indices here. So that's why if the summation doesn't depend on the indices, then this type of indices is called the dummy indices. So all the indices here are called the dummy indices, right? Okay, so I'm going to make you understand what is free indices. Then if you understand what is free indices, then it'd be really better for you to understand the dummy indices. Okay, let's go to the free indices. So now I'm going to teach you about what is free indices. So free indices. So free indices. So what is free indices in a tensor or something? So just going to make a change color so that it be beautiful. Yep. Say, say for example, we have system of equations here. To make you understand, I'm going to write down this. Yeah, x1 prime equal to system of three equations here. Say a1 x1 plus a12 x2 plus a13 x3, right? So we have a three equations, something like that. 2 prime here, a21 x2 plus a22 x2, sorry, this should be 1, I'm sorry. Yeah, so a23 x3, right? So and we have three equations here, so 3. Yep, so here you have c1 x1 plus a32 x2 plus a33 x3, right? So we have three system of equations. So in compact form, if we write down this equation in compact form, then we can write down here x1 prime equal to, so for example, I'm going to make you understand. Here the two indices here at a, right, 1 and 1, and at the and at x we have one indices, right? Here, so make the color change, it be better for me and better for you as well. Yeah, so here the different indices 2 1 1 and 1, two indices is 1 2 and 2, right? So the most interesting part is the indices at x is equal to the second indices of a, right? So if we, and the first indices is same as the x1 here, and every equation it is 2, so it is 2, it is 2. The second indices of a is equal to the indices of x, so and the first index is equal to the x2, right? So how we can write down is compact form. So so the indices of first indices of a should be the same as x, so this should be the 1, right? And the second indices of a and x should be the same. So if we say it is I or j, say it is j, then definitely we should put here this is the j, right? Yeah, same way you can write down the compact form of the second equation. So how we can write down, so x2 prime equal to a to j equal to xj, right? Yeah, this and third equation, so you can write down 3 prime equal to a3 j xj, right? Yeah, so we have we have system of equations and three equations, and we write down here in compact form this, right? So uh, and which can be shortened into, and these three equations can be further shortened or further compacted to the following equations. Say for example here, so we can write down three equations. So we know this, the first indices is same of a is same as the x, right? The indices of x, so it's 2 here, 2 here, 3 here, here 3. So we can write down here x I prime equal to a I j equal to x j, right? So these are the most shortened or most compact form of those above three equations, right? Okay, so an index that appears only once in each term of an equation, such as index I, right? Here in the above equation, we say I is the indices which appears only once in only uh, on each term of equation. So that here is the term, right? Here is the term. So in each term we have only one is one time. So here in this term here one is one time. So as the so we can say the index that appears only once in each term of an equation, such as here index I in the above equations, is called the free index, right? Unless otherwise stated. Yeah. So this is very important. That's why you say I is the free indices. So I'm sure you have understood the what is the free indices is, right? So in each term we have t is 1, so t is the free indices here in this term. So t here 1 time, so this t is the free indices in this term here as well. So that's why we call the free indices here according to this. Okay, I'll make you understand about this more details. Okay, so thank you. I hope you've understood what are the dummy indices and what are the free indices. So it will make you, it will help you to more understand everything in later lectures, because the later lectures are more about the free indices and dummy indices on the basis of free indices and dummy indices. Because if you don't understand these indices or what is the how can that done systemification in a compact form, then it will be really difficult for you to make you understand. So I recommend you to go through a book, and it'd be really helpful. Okay, so I'm going to give you a reference book which I'm going to follow here in this lecture. So it's nothing but is the introduction to continuum mechanics, which is fourth edition. I'm following the fourth edition. I'm following the Michel. Okay, I'm going to write down here the reference book here, and other also several other books will be followed here. So the book is here. I'm going to reference book. I'm going to write down here reference book. So what is the book here? Reference book. Reference book is here. Introduction to Continuum Mechanics. Introduction to TNU Continuum Mechanics. NECA. NIC Continuum. This is really good books, right? So it's the fourth edition. It's the fourth edition. Authors are here. I'm going to write down the author's name here. MICHA EL Michel Lai, LM Lai. Number one author. Number two author is ERAARD Campbell. KREMPL. And third author here is David Rubin. Yeah. DAVIDRUBEN. So I'm going to follow this book. Apart from this, I'm going to follow some other books as well. So I'm going to write down all the books. So what I'm going to follow. So here in geodynamics, I'm going to follow the geodynamics. And then there is a book called geodynamics to her and some other books. Okay. So in the lecture, I'll give you the book name and book names and other references. Sometimes I would use internet or some copy paste from internet, something like that, to make you understand. I hope you understand that it's very difficult to make lectures online. Okay, thank you very much, and I will see you the next lecture. Thank you.